All right, so we're talking about exponential function in their graph. We're going to learn how to graph an exponential function today. Okay. So the exponential function f with a base of a is denoted by this. Do you have to write that down? Mm-hmm. Yep. Okay, so go ahead and fill in the blanks. I know you got to read a little bit and fill them in. So fill in the blanks. Okay, so an exponential function, it's something that looks like, let me write it down. Okay. Let's see how this goes. So it's something that looks like 2 to the x power, okay, where the variable is the exponent. All right, so that's what an exponential is. The a value, this number here, is typically a number that's bigger than 0. If we put a negative in front, it's not part of this chunk here. It means times -1, and that's what does like the flip upside down, okay? A is typically not 1, okay, because 1 to any number is just 1. And x can be any real number. So this could be a positive or a negative. It could be a fraction, okay? It could be a decimal point. So the first thing is we're going to use the calculator to evaluate the function at the indicated value of x and round the result 3 decimal places. Okay, so let's use our calculator to do that. That's why you need your calculators today. All right, so 2 to the -3.1 power. Actually, before I... All right, so we're going to go to our calculator. And we could go to... I'm going to hit that. So I'm going to go to my scratch pad. And you're going to pick 2. And you're going to use the caret button. To the end, it was -3.1, right? Hit enter. All right, so it looks like we would write down, we got to go 3 decimal places, 117 maybe? Does that sound about right? All right, so I would probably write that it was 117. Probably when you write your workout on this one, I would probably just write 2 to the -3.1 equals 0.117. Okay? All right, there's 2 more of those, aren't there? Oh, we got to do pi. Let's do that together. Okay? I'm going to show you. All right, so on this calculator, and again, you could do this with, a lot of your phones have a scientific on it, right? Have you ever seen the button? It's typically the button. Oh, not that presentation. Just so you guys know, there's a button on. Sometimes on the phone. I don't remember. Y to the X or X to the Y is the same thing as the caret button. Okay. If you don't have it on your phone, sometimes if you turn your phone sideways, that'll turn it into the scientific calculator. Okay. The other one is it is on the computer too. If you look at the calculator, there's a way to change it to scientific too. Okay, I can show you that in a minute. But let's go ahead. Let's try to find pi. So the next one was 2 to the -pi, right? Because it's a negative x. Do you see the negative on there? So 2 caret. We're going to type in the negative symbol. And then look on the left-hand side of the alphabet and look for the pi.
Good morning, students. Welcome back, teachers, of course. Hey, one more brief announcement. If our teachers on prep and our sophomore teachers, they're going to have students in their class, of course, should be in the theater at this time. So if you do not have students at this point, if you can please head to the theater. Thank you.
All right, so what would we write down for our decimal on that one? Point what?
0.112.
1. I'd go 3. Okay, so 0.113. All right, and then the next one is 3/2. All right, the next one is 3/2. So the next one says 0.6 to the 3/2. So I'm going to type in a 0.6. Do I really need the 0 in front of the 0.6? No. So to the, and then I could do my control divide in there. So I can hit that control divide and make my fractional exponent, or you can hit the divide key, your choice. 3/2 and hit enter. So 0.465 maybe? Okay. Awesome. All right, I'm going to go back. Hopefully you wrote down the answers for those three, right? So I'm not going to write them down. All right, there's the next part. You got to fill in a bunch of blanks, right? So it looks like it's in the middle of that chart, isn't it? So right in here is the information that you need. Okay, so I'm going to give you a couple minutes. Everybody write that down right now. All right, you ready? Or not yet? Okay, so just like all of our other parent graphs, these are the parent graphs for exponential. And you'll notice one of them is always increasing and one of them is always decreasing, and it just depends on the exponent. This is saying that if you have a positive exponent, that it's going to be this increasing graph. If you have a negative exponent, it's going to be the decreasing graph. Okay? And really, if you think about it, it's just a horizontal reflection, kind of. The domain is all numbers. The range, notice it starts at 0. Okay, so it starts here and it goes up on both of them. If you had a negative in front, that would flip it down. Okay. It always starts with this intercept 0, 1. Hopefully that's on most of the graphs unless we change them in some way. It's always increasing. This one's always decreasing. The x-axis is a horizontal asymptote. This one always goes as we get closer to 0, the x value goes to negative infinity. This one, as we get closer to 0, the x value goes closer to 0, we go towards positive infinity. Okay, and they're all continuous. All right, so what they want us to do is they want us to graph. There's another little box though, right? It's that box, isn't it? Fill that in. I'm not sure 5 points are really necessary. I would say 2 or 3 is probably plenty. Okay. All right, so to graph them, we're going to fill out a table of values. I didn't read the instructions very well. Okay. So this is going to be x, and it's going to be f of x. So x, f of x. And I'm going to choose to do -1, 0, and 1. Because that would make it some that are less than 0, some that are bigger than 0. Again, I can do this with 3. They said 5. Well, I think 3 is enough for most of them. There's one here that I make you do 5. And you'll see why. So I'm going to put in this, I'm basically going to sub into this problem right here. So I get 3 to the -1 power. And I can crank this one by hand. It's not that hard. That says it's not happy where he's at, right? So isn't that the same as saying 1/3? I bring it down. I bring the exponent. I have to bring it downstairs to make it happy. I put in a 0 power. Anything to the 0 power is always what? 1, good. And then 3 to the first is just 3. So I'm going to plot those points. So I'm going to go -1 and 1/3. I'm going to go 0, 1, and you're going to go 1, 3. And we know that it's supposed to be flat and increase, or it does the decrease and then goes flat. That's just the nature of the graph. Okay. It asks us, and after that, to identify asymptotes, intercepts, and determine whether the graph of the function is increasing, decreasing. So do you see how we know the asymptote is supposed to be the x-axis unless for some reason something's being added or subtracted?
Teachers, our sophomores have just been released from the theater. Please allow them in class. Again, sophomores are on their way to second period.
Awesome. All right. So y equals 0. And then our intercept is just this point, isn't it? Yep. So my intercept is just out 0, up 1. And then is this function increasing or decreasing? Increasing. All right, let's look at the next one. So again, we're going to come up with our little chart. So I'm going to go x, f of x. What are the 3 values that we like to pick? -1, 0, 1. Good. Those might not work if the graph is shifted a little bit. Sometimes we have to go one direction or the other. Okay, but they'll work for now. So I'm going to put in 4 to the -1. Let me rewrite that. I didn't quite, it was running into my f of x. So I didn't write then a negative. So it's negative from the problem, and then we're subbing in a -1. So what happens with the double negative? Positive. So I end up with 4. I get 4 to the -0. Anything to the 0 power is what? 1. And then 4 to the -1. Is the exponent happy? No, so I'm going to move it downstairs so we get 1/4. So we're going to go out -1 and up 4. We're going to go out 0 and up 1. That's my intercept, right? And then out 1, up 1/4. And we're going to start steep and curve it down to flat. Oh, that did not start. Mine is not good. I've got little lumps in there. Don't make little lumps. All right, so my asymptote, again, is the x-axis. And the way we write the x-axis is y equals 0. Your asymptote is always going to be a y equals something today, okay? And then we've got the intercept is our 0, 1. And is that one increasing or decreasing? It's decreasing, right? Because remember, we always read from left to right. We know that that graph is always going down, so that one's a decreasing graph. All right. Let's look at the next one here. All right, so I'm going to give you a minute or so. Go ahead and fill in all those blanks. All right, we got it? Yeah? Okay, this is the same stuff we've been doing forever, okay? And when it's in the exponent, when it's with the x, remember how we switch the sign when it's in parentheses? That exponent is acting like the parentheses, okay? So if I think about it, it's really a -1 shift, so that would go to the left, Okay, this one would make it positive 1, so it makes it go to the right. Notice it's not in the exponent anymore. Okay, so it's a y shift when it's not in the exponent with the x. So that's going up, and we don't change the sign on the y shift, and then it's going down. Okay, the negative in front is always a reflection in the x. We've already seen this one, though, this period. A negative in the exponent is a reflection across the y. Okay, so basically, these are really good multiple choice test questions right here, right? It's to talk about the shifting, okay, or multiple response. All right, so we're going to use the graph of y equals 4 to the x to match the function with its graph. This one here should be an exponent. It should say 4 to the x minus 2, and I know that that typo's in your notebooks as well, right? If not, it's a line. Okay, so let's talk about what would happen here. So we've got a negative in front of the x. So how is that going to change it? What are we going to do, guys? I'll close it. It's going to reflect across the y-axis. So write that down. Reflection in the y-axis. Okay. So reflection in the y-axis. And I'd write down what it is because in your notes. You don't have to tell me what it is in the homework. So which one is that going to match to in those 3 pictures? B. Okay. All right. Remember when it's up in the exponent, it acts with the x. So is it going to be a left-right movement or an up-down movement? When we're up in the x, we're doing, look back at here. It's going to be either left or right. So remember, you have to do opposite signs. So it's acting like a -3. So does it move to the left or does it move to the right? Left. Good. So it's going to shift left 3. So which graph is that going to be? It's going to be C. Good. Okay. All right. This one is not up in the exponent. So when it's not up in the exponent, is going to be a left-right movement or an up-down movement? It's going to be an up-down movement. And in this case, what's it going to do? Good. It's going to shift down 2. So it better be graph A, right? Now, if it was matching, that would be great, right? Although I could add extra ones in there to confuse you, right? If it was like that on the final. Multiple choice, I would be prepared that it's going to be, it would have something there to confuse you, okay? All right. This one is really messed up compared to yours. So let's see. A was okay. B, yours had a negative, and then it was a +6, wasn't it? And then letter C was 3 to the -x, and then it was a -4. Does that fix it up to look just like yours? Okay, awesome. We're going to describe the transformation that yields the graph. So, I don't have the picture, but I can still describe the transformation, right? So again, when we're up in the x, we're in the exponent, are we shifting to the left, right, or up and down? Left, right. Okay, so in this case, remember, you're changing your sign. So is it a left movement or a right movement? Left. So we're going to go shift, left, 1. We're on page 126 in your notes right now. Okay? All right. On this one right here, okay, we have a negative in front. So what's the negative in front going to do? Reflect on the x-axis or in the x-axis. Okay. What about the +6? How's that going to move it? Up. Good. So shift up 6. All right. Looking at C, what's the negative on the x going to do in the exponent? Reflect in the y. Good. So reflection in the y-axis. Okay. And then what's the -4 out back going to do? Shift down 4. Good. All right, everybody got example 7? Okay. Go ahead and fill in those blanks. I'm going to retake attendance here. Okay. Sophomores, you're all now marked here. Okay, so you guys know pi, right? 3.14159 and so on and so on and so on. It's a number, right? E is another number. Okay? It's 2.718218828 and it goes on and on and on forever. Okay? It should really have the ... after it. So you just need to understand that e is the number and x is the exponent. So anytime you see e to the x, it's really like saying 2.718 to the x power. Okay? And so, or whatever the decimal is in the x power. Okay? It still is an exponential number, or an exponential function. Okay, so we're going to use our calculator to evaluate. The sophomores came back for the really hard part. To evaluate the function of the indicated value of x, we're going to round 3 decimal places. So you're going to basically do e squared. But we're not typing in 2.718. We're actually going to use the e button. And on this calculator and on, go ahead and hit Doc B. Clear it out. And on any of your scientifics, there should be an e button. Do you see how where the caret button is we were using earlier? Go down underneath it. It's e. Notice it's bold. Okay, it's a bold E, and we said we were going to square it. So we would write down 0.7389, right? That would be rounded properly, 0.7389. So 7.389. I'm sorry, I said it wrong. 7.389. Okay. I think you guys can try. Everybody do the next one. Put it in your calculator. Okay? E to the negative 0.4. You don't really need the 0. All right, what'd you guys get? 0.670. That? Nothing in front? Awesome. Okay. That one's a little bit different, right? I'll do that one with you. So we've got to do 20 first. Okay, so we can do you can use the calculator to do all of the work for us. So we're going to type in 20. And then we're going to do E. And then it was a -2, wasn't it? -2, so -2, and then hit your times key, and 0.01. So 19.604. Everybody good with that? All right, let me go back here. 19.604. So probably when I'm doing my homework, I would write down f of 0.01 equals 20e to the -0.2 times, or -2 times 0.01, and we said it was what again? 19.604. Okay. All right, I'm going to give you a minute. Everybody write those 3 down. Okay, and then we're going to talk about 11 and 12, and that's it. So juniors, you'll be good to go. Okay, because you're leaving probably in a few minutes. Sophomores, maybe we'll go by, be nice and go back to the beginning for you. It's pretty easy today. I did record it though, so it will go up. In fact, we're recording right now because I realized I messed up during first period. So, okay, we good? So we're gonna sketch the graph of an exponential. I'm gonna do the kind of use the calculator, help us make the table. Then we're gonna plot points. And then we're gonna connect them with the smooth curve. Okay. I unfortunately did not give you a graph patch. You're gonna have to draw your own graph patch, and we're gonna draw a t-chart. So that's what you need room for. Okay, so x, y. Now, earlier in the lesson I said, let's do 3 points. On this particular one, you'll see why in a second. 5 is probably more reasonable, just to make sure we get a good picture. So I'm going to do those. Those are some good numbers. If you're going to do 3, at least -1, 0, and 1. Okay? All right. It should not, the reason I'm doing 5 is if I don't, it looks kind of like a parabola, okay, when I graph it. So 5 makes it better. But we're going to do this a little bit differently than we did before, okay? So let's put this function here into your graph part. So I'm going to hit a dock B and get rid of everything again. Kind of clears my screen for me. All right, and then it was 4 to the negative x squared. Go ahead and graph it. All right, I'm hitting graph. Do you see how if I just put in that -1 and the 1, I would probably get a parabola shape. I wouldn't get these extra lines out there. Okay, so that's why I put in 5 this time. But I'm going to do the table similar to what I did before. So I'm going to go var f1 of -2. Oh, and watch this. So here's how you get the decimal point. Hit Control Enter, and it gives you the decimal point. And you don't have to, so if I did var f1 of 2, if I did the other end, because it's going to come out to be a decimal 2, I can hit Control Enter to start with, and it's going to give me the decimal. Okay? Is that a nice little trick? So var f1 of -1, and it's up to you. It's just 1/4. We can hopefully do that one in our head. Control var, oops, that's not what I wanted. Var f1 0, and then var f1 of 1. All right, what were my other two numbers? It was 0, 0, 3, 9. Okay, so let's fill in our table. So 0.0039, this was 1/4, 0, 1/4, and 0.0039. And again, you're going to do a sloppy graph. We're going to get the idea. So for the work in your homework, you're going to show me your value of tables, and you're going to sketch your graph. Okay? And then we'll identify the asymptotes here in a second. So -2, and barely see it above the axis. Same thing with 2. Notice I scaled my graph so I could make it, I could actually see what I was doing here. And then 1. And we're going to go low, high, low. I should be able, oh, that's horrible. It shouldn't go up like that. Do the best you can, right? Make it hug the axis. It shouldn't, I should be able to give you any random graph and you sketch it with a chart, right? It does ask us to identify asymptotes. So do you notice how it never goes below the y-axis there? So our asymptote would be y equals 0. I'm going to show you in a minute here. It's not in the notes, but I will show you a quick way to identify asymptotes here in a second. All right, let's try putting that one in now. Okay, we're going to do a t-chart. Let's do the same 5 values, -2, -1, 0, 1, and 2. So I'd hit a dock B, and we're also going to sketch it. So let's hit a dock B to clear. So dock B. All right, and let's type in, it was a 1/2, so it's up to you. You can hit a control divide, or you can hit type in 0.5, that works too. And then E, so I'm going to use my E button again. Oh, I hit my natural log, sorry. We'll talk about that later in the week. E to the -0.58, -0.58x, and hit enter. Now, that's the picture, but I want the numbers, right? The numbers were verifying that I knew what I was doing. So var f1, and we're going to do -2. Var f1, -1. Var f1 of 0. var f1 of 1 and var f1 of 2. Okay, there's my new t-chart. How do you like that? That's really cheating, isn't it? There we go. X, Y. Pretend it's 3 decimal places. Okay, so I'm gonna go ahead and plot that. Okay, so we had -2 and 1.59. -1 and 0.89. This is an instance where we don't have that 0.10 or 0.1 because of the number, the 1/2 in front squished it. And then that 0.27 and we get closer to 0. Sketch the graph going through it. Again, what's the asymptote? Y equals 0. All right, before I let you loose on the homework and let the juniors loose on the homework here, let's talk about asymptotes for a minute and a really easy way to identify them. Okay? So here's what I want you to do. Let's play with it in the calculator. Let's leave the one you have in the calculator in there. Okay? And I want you to go back to the equation for it and just put a +1 on the end. And hit enter. And I'm going to do something extra on mine here. What do you notice about the +1? It moved up 1, but isn't that the asymptote? Look up at mine at the red line. Didn't that become the asymptote? Now let's try this one. To go back to the function again and go -1 instead of +1. So retype it and hit -1. I'm going to fix mine up here. So isn't it the y value that determines the asymptote?